Hello again. We are just about ready to move on to our next official page in our Math Binder, but I wanted to refresh your memories on something from that I'm hoping you probably saw in elementary real quick. Does this look at all familiar to you? It's totally possible that in 6th grade or maybe even 5th grade, you looked at some positive and negative tiles to help you understand what's going on here. So with the can you breathe task, we refreshed that you can consider positives and negatives on a number line, either a vertical number line or a horizontal number line. You probably worked with some number lines in elementary as well. That's a visual mathematical model. Another way that we model this mathematics in elementary is with positive versus negative tiles. And then what we realize and what we look for is something called a zero pair. Of course, if I have one positive and one negative, then those are going to cancel each other out. Those are going to zero each other out. And I have 4 of those zero pairs, and then I can simply look at what is left, 3 positive values. Now, as I mentioned before, our goal this year in our secondary mathematics is to get to a point where we maybe don't have to draw these visual models. They are an excellent way to introduce yourself to it and help yourself figure it out. But now turn your attention to page 2 in your math binder. So remember, this is page 1. We got the can you breathe task. Flip it over to the other side and you'll see a little 2 right here. If you want to keep it in your math binder and write in it, you can. If you want to unclip it to write in it, you can. Now here on the top gives us a really good example of why we need a more efficient method than drawing positive and negative tiles or trying to sketch it all out on a number line. Because in real life, we get a lot of problems like this. And as it says up here, it says the following problems are too large for a model. Now it's not impossible, you could do it, okay? You could draw 100 negative tiles and you could draw 96 negative tiles. You could totally do that. I personally don't want to. And I'm guessing maybe you don't want to either. So let's just think through. It says guess the answer. Well, when I can't draw the tiles or I can't draw the number line, I still can absolutely picture it in my mind. If I drew 100 negative tiles and I drew 96 more negative tiles, what am I looking at there in front of me? Well, I'm looking at a whole bunch of negative tiles, right? And if I have 100 negative tiles and 96 more negative tiles, did I get any zero pairs to cancel away? Well, no, I didn't. So all that's going to happen here is all these negatives are going to go together. I'm still going to have a whole bunch of negative tiles. I'm just going to have 196 total of them now. Okay. So if I have a bunch of negative tiles and a bunch more negative tiles, all I'm going to do is put them together. All right. Look at this one. Imagine drawing it. Don't actually physically draw it because that's a lot of tiles to draw. And the fact of the matter is too, when these numbers get too big, we are humans and we miscount and we make mistakes when we try to draw those. So let's get ourselves to a place where we can rely on more mathematical processes. So imagine this. If I drew 105 negative tiles and I drew 84 positive tiles, I don't necessarily have to draw it to imagine what's going to happen. How many zero pairs am I going to have? How many values are going to cancel out? Are 105 of them going to cancel out? Or are 84 of them going to cancel out? And this is the point in class where someone will almost always say, it's always going to be the smaller one. The smaller one's going to cancel out. Well, be careful of that language in mathematics because technically negatives are always smaller than positives, right? So this is where we start to think of things as which one goes farther from 0, okay? Does 105 go farther from 0 or does 84 go farther from 0, okay? So the 105 goes farther from 0 and that tells me a couple things and I'm going to use that mathematics there. Now what that means is when I have a bunch of negative tiles along with positive tiles, and we're going to give mathematical names to all of these things in just a second. But when I have different types of tiles instead of the same types of tiles, I can't just put everything together. I recognize that a bunch of zero pairs are going to cancel. Well, let's think about over here. If a bunch of zero pairs were going to cancel, if I'm canceling things away, isn't that really just subtraction? Isn't that really what I'm doing when I'm canceling zero pairs is I'm subtracting stuff out? And look at this, 7 minus 4 equals 3. Okay, so if I can just subtract these and go from there, then maybe I can figure out those answers. Okay, so I could even just do my basic subtraction and figure this out here, 21. But here's the thing. Am I going to be left with, if you imagine drawing all these tiles, am I going to be left with 21 positive tiles, or am I going to be left with 21 negative tiles? Well, if I'd have drawn this out, I'd have been drawing more negative tiles. So I would have been left with negative tiles. Okay, now, and something like this, hopefully we get pretty good at, but this means everything. If I drew 204 negative tiles and 204 positive tiles, everything turns into a 0 pair, and those are opposites, and they simply turn to 0. So let's make this a little bit more mathematical. Let's get to a point where we can really get what's going on in our heads based on the mathematics you learned in elementary. And let's take it to a point where I don't have to draw out a bazillion tiles. Let's just say, what is the mathematics going on here, and how do I use the mathematics? So when they say same signs in math, okay, so up here, just so you don't miss all this stuff that it's talking about, some formatting in these notes here. So these are more solidifying notes. On this side of the page, we were doing a task where you guys were trying it, and we all had different methods and we're trying different things, and that was great, and then we came together and made it a mathematical process. This is called notes, which is a little bit more guided, solidifying. That means everything I'm writing down right now, you should be watching and listening and writing with me. And of course, if you miss something, pause it, rewind it, whatever you got to do. So a same sign situation is like this right here. Same signs meaning you would draw all negative tiles or you would draw all positive tiles. So it says up here, these are rules for adding integers. That means we're not going to run into any decimals or fractions just yet. Those are the rest of the rational numbers. Okay, but right now we're just going to focus on positives and negatives, and we'll define a lot of that more officially as we go. So the same signs rule says this. So right here, do you see where I'm at? I'm in this box that says same signs. I got my pen ready, and I'm going to say it out loud, and I'm going to write it down, and you need to write it too. So the same signs rule is simple to start. You add. If you have same signs, imagine this, if I had 100 negative tiles and 96 more negative tiles, all I'm doing is adding them all together. So if I have same signs, add, but this part's really, really important. Same signs, add, and keep the common sign. I'm going to show you a couple of examples of what I mean here, okay? So in terms of numbers, for example, I have an example right there, but let me give you a different one. So if I just do 10 plus 15, that's a basic addition problem from elementary, but it's actually a same sign scenario. I would draw 10 positive tiles, 15 more positive tiles, and I would simply add them all together. Now, the keep the common sign means if you started with 2 positives, your answer is still positive, okay? So same signs add, keep the common sign. Now, of course, if I'm doing this and I change these both to negative, the keep the common sign means now my answer is a negative 25. All right, so same signs add, keep the common sign. You'll hear me say that a lot in these videos. Same signs add, keep the common sign. I'm going to give you a little shortcut over here too, because there are a couple things I've used in my life that help me remember this, so I'm going to share them with you. And this is also a good time for me to point out this section right here. Now, we didn't have that on our task here because this was just exploring and discovering, and however you did it was great. This, when you have notes, you'll often see that I'll throw in little sections like this. Whatever I'm writing on the rest of it, I need you to write the exact same stuff. But this part over here is really for you. If you hear me say something that I don't write down that you're like, oh, that's a good thing to remember, you can write it over here, okay? In these first couple pages, I'll give you some examples of things you can write over there. For example, right here, one of the things that helps me remember is this word sum. We know the word sum means addition, and that's a big part of this rule, right? So one of the things that I've always remembered is same signs sum. And you can write that down however makes sense to you, but they both start with S's, so that helps us remember. Same sign sum. And sometimes I'll even doodle like a little You can make your notes whatever you want. They're for you. So do it in a way that you can read it later. These notes are all for present you and future you. So do it in a way that you can read it later, you can understand it later. But same signs add, keep the common sign. You can also remember same signs sum, so that can help you remember to add, okay? And we're gonna practice this a lot over the next couple of days. Right now, get it all written down. So different signs, that is an example like this right here. Notice I had negatives and I had positives. In that case, when you have different signs, you're going to have negative tiles and positive tiles, and you're not just going to combine them all. Some of them are going to cancel. And because some of them cancel, different signs is now a subtraction. Okay, this gets a little tricky, so watch this. You're going to subtract. That's definitely the first part. But this part's really important and a little bit trickier than this. Up here, you just get to keep the common sign. With different signs, you have to subtract, and then you have to decide this, okay? You ready? We are going to then take the sign of the one that, still with me? Take the sign of the one that goes farther. And I'm going to put in parentheses because that's what I say out loud all the time. I say subtract, take the sign of the one that goes farther. But I'm going to put in parentheses that means farther from 0. I don't always say that whole part, so you can remember that. But when we're talking about take the sign of the one that goes farther, you look at which one actually takes you farther from 0 on a number line. And whichever one takes you farther from 0, that's the ones that you're going to have left over, because that's what you have more of. So up here we said we had more negatives because this goes farther from 0 than this. So your answer will be negative. So let me show you a couple of examples there. So if I had, and I can keep using these numbers 10 and 15 to illustrate, if I had negative 10 plus 15, now I'm looking at a different signs scenario. And the different signs scenario tells me different signs subtract. So the very first thing I'm going to do is subtract. Now, when you do your basic subtraction, sometimes people get all wrapped up in the order. I'm supposed to do 10 minus 15, right? Well, no, because addition, I don't know if you remember this terminology from elementary, but addition is commutative and the order doesn't matter. What matters is the signs. Am I dealing with positives or negatives, and how does that impact my answer? So if I say different signs subtract, I'm immediately, because I know this is the next part, I'm immediately thinking which one's farther from 0. I'm already thinking of that. And I know that 15 is farther from 0 than 10. I need that value for 2 reasons. One, because I need to know what to do to finish this rule. But 2, and here's how I'm going to use it right now, that always determines the order that I subtract things. So if I say, okay, 15 is farther from 0, then I can just go 15 minus 10. Okay, 15 minus 10 is 5. Here's my question though, should that answer be positive 5 or negative 5? Okay, and here's where I do this part. Take the sign of the one that goes farther. Okay, so we already decided 15 goes farther from 0 and 15 is positive. And in case you're like, how does she know? Well, you look directly in front of the number. Directly in front of this 10, what came before the 10 tells me this is a negative. What came before the 15 tells me this is a positive. Okay, so now if I switch these, watch what happens. What if I do 10 plus negative 15? We already know and have already determined that 15 is farther from 0. So I'm going to do the same subtraction. 15 minus 10 is 5, but now I'm going to take the sign of the one that goes farther. So negative 10 plus 15 is positive 5. 10 plus negative 15 is negative 5. I'm going to say this one more time. Subtract and take the sign of the one that goes farther. Now I'm going to add a little speech bubble over here too, because sum is the official math word for the answer to an addition problem. What is it for subtraction? Oh yeah, difference. So that's nice. So different signs, you can actually remember, goes along with the word difference. And I'm adding these things here so you can use whatever makes sense to you, okay? Same sign sum, different signs difference. But then you do also have to remember what to do with the sign. Do what makes sense when you're finished with that part. So same signs add, keep the common sign. Different signs subtract, take the sign of the one that goes farther. But you can also remember same signs sum, different signs difference. Okay, now opposites, and this is just a simple one to keep in mind, because if you run into something that's opposites, that's this. okay? If you run into something that's opposites, you can simply remember that you don't have to add or subtract. The answer will always be 0. And I'll give you a couple of examples. Doesn't matter how big or small the numbers are. But if I had 10 plus negative 10, those are considered opposites because it's the exact same number of positives as it is negatives. And if I asked you which one's farther from 0, oh, the answer is they are the exact same distance from 0. So that is truly what makes them opposites. If I place these on a number line, they are the same distance from 0. So that gives me an answer of 0. I could do, if I make the negative first, that's okay too. I could do negative 12 plus 12. And those are still considered opposites because if I asked you which one's farther from 0, well, neither. They're the same distance from 0. So this one, it helps me if I remember. I don't have a quick little mnemonic device like this, but I do remember that opposites give me no 0 pairs. They are the same distance from 0. No 0 pairs. What nonsense. All 0 pairs. That's what I meant to say there. Opposites give me all 0 pairs. Everything would be a 0 pair. If I did 10 positives and 10 negatives, all of them would be 0 pairs, and it would leave me all with 0. Okay, here is what I want you to try now. Just like we did in the last video, I will often ask you to pause me and then try something. Now, obviously, as you're sitting there and doing it, I can usually tell from the timestamps if you actually did, but for the most part, I'm just asking you to do it because it is a much better way for you to process and understand your mathematics. So it's always a really good idea if you try some examples before I just show them to you. Okay, so and sometimes people on this part where they're like, I'm going to try it and then she's going to show me. Some people on this part like to switch to a pencil here because if you get it wrong, getting things wrong in math class is so wonderful. It's a mistake-making, risk-taking type of adventure mathematics, and making those mistakes helps you learn so much more. I love mistakes. I often pick my favorite mistakes that students make, and you'll hear me share them with you because I've taught long enough that I know the mistakes, and I love the mistakes. We get so much good learning from mistakes, but sometimes, so people, when they're working through it and they actually pause their video and try it, sometimes people will switch to a pencil at this point. So then when I come back and share my favorite mistakes and check what you're doing, you can easily change and fix things if you need to. Now, sometimes I'll tell students, like, try it on your own, and then I'll say, don't even erase it. If you find out you did something wrong, don't even erase it. Just cross it off and show yourself the right way, because then you still have a visual of your learning experience. Again, these notes are for you. So, and for future you. So you do whatever is going to make the most sense to you as you look back on them later. But what you're going to do right now is you're going to pause me for a minute and you're going to try and follow these rules. Now, if you need to draw a model here or there, that's always okay. But you will become a much more efficient mathematician if you can follow these rules. So just to get you started, the very first question you should ask yourself, maybe I'll do the first two with you and then I'll set you loose. The very first question you should ask yourself is, am I dealing with same signs or different signs? Because you can't even know what rule to use if you don't recognize that, right? So that's the very first thing I ask myself when looking at a problem like this. And I see a negative 14 and a negative 11. This is a same signs scenario. What's this one, guys? Same signs. Okay, this is same signs. So I say to myself in my head, same signs add, keep the common sign. And if I need to do a little scratch work over here, that is always just fine. When we say same signs add, it's the addition that you know, and adding those numbers together. And now I apply the next part. Same signs add, keep the common sign. So my final answer is negative 25. Same signs add, keep the common sign. Now, one more, take a look at this one. The first question you should always ask yourself is, same signs or different signs? Right here, I have different signs. Different signs subtract. So that's my very first thing. And I can probably subtract this in my head, but if future you wants to remember what you were doing, you can give yourself a little math statement over here. And sometimes the numbers get bigger and this little scratch work helps a lot. So different signs subtract. So I know this is involved, but now I have to apply the rest of that rule. Different signs subtract. Take the sign of the one that goes farther. Which one goes farther from 0? 14 or 11? 14 does. So I keep this a positive. Do I need to write a plus in front of it? No. Can I? Sure. Sometimes that gets confusing because we use that more as an addition symbol. And so the accepted notation in mathematics is if you write nothing, you're dealing with a positive number. If you write a negative, you're dealing with a negative. Okay, now you're going to pause me, try the rest of these, and then come back and see how you do. Pause. Ta-da! Let's see how we did. So we finished 4 and 5, so starting right here. Now I wrote off to the side so that you can see exactly what I'm doing, but I'm going to talk out loud the thought process I went through on each of these. Here's what I did. Different signs subtract. Take the sign of the one that goes farther. 14 is farther from 0. So this one's negative. Look at this. Different signs. Do we recognize this as different signs? Different signs subtract. Take the sign of the one that goes farther. 38 goes farther from 0. Different signs subtract. Take the sign of the one that goes farther. 3 goes farther than 2. So negative. Why? Because the 3 was negative. Take the sign of the one that goes farther from 0. This one is same signs. Same signs add, keep the common sign. This is a really common one where students will accidentally write 0. This row right here will sometimes get mixed up. So let's take a look at it. Follow the rules. Watch this. Same signs. Those are same signs. You see that? Same signs add, keep the common sign. Now this is actually an opposites where it's all 0 pairs. So you probably noticed that pretty quickly, but even if you don't, it's actually a different sign scenario. And if you subtract, because it's different signs, 6 minus 6 is still 0. And 0 is neutral. It's neither positive nor is it negative. Okay, different sign subtract, take the sign of one goes farther, which there isn't one in this case, it's just 0. Now, look what happens when I have 3, which number 13 was just different sign subtract, take the sign of one that goes farther. 78 is certainly farther from 0 than 10, so I left it positive. When I have multiple, you can choose the order because it's addition. So you can switch things around, you can change the order, you can do whatever you want in that way. What I personally find to be the easiest is if I have more than 2 numbers, I find the ones that are same signs because then I can do same signs add. And that just feels more efficient. It feels simpler to me. So these are same signs, so I added them. You might have worked these in a totally different order, and that's fine as long as you got to the same result. So I went same signs add, keep the common sign to get this -7 here. Then I brought this down and now I went, oh, okay, now I have different signs subtract, take the sign of the one that goes farther. Okay, same signs add, keep the common sign. Oh, look at that, now it's opposites, all 0 pairs. Same signs add, keep the common sign. Now different signs subtract, take the sign of the one that goes farther. So when you have more than one value that you're adding or subtracting, combine the same ones first and then go from there. Okay, you guys are now ready to try this on your next quiz, but I want to show you, just since it's the first week and we're still getting used to all of this stuff, you should now have, let me show you what your binder should look like right now, because I'm going to tell you also there are going to be binder checks. Digitally, you're going to show me pictures of things, and we'll talk about that a little bit more tomorrow. But you should now have, I'm going to take this page and I'm going to put it safely back into my math binder. Look, I've got pages 1 and 2. They're all filled out. I'm going to clip that safely in there. I'm making my book. I'm completing things. It's awesome. Now, if I flip back to behind this pink paper, I should now have, you should have this page all filled out for the first quiz. You also did a homework quiz yesterday called NS.1B. Remember, NS stands for the number system. That's what we're working on right now is number system standard 1. You should have NS.1B, positives and negatives, with all your answers written here. And now you're going to fill out this one. So you should have your third one filled out after today. You're going to put a title on it. You're going to write number 1, and you're going to start showing all your work. Okay. Now this might mean, let me share the other screen with you and show you really quickly. So this is what you're looking at. says right here, label your paper with ns.1c adding integers. Those are always the big titles up here on the screen in case you're not sure where you're getting those labels from. They're the big titles up here. That's what you write down. And then this is where you start writing things. You could copy that question. You could just write down your answer. If you can see this one really quickly and easily, you can at the very least write down your answer, even when it's multiple choice, you guys. Especially when it's multiple choice. You guys are very click happy on multiple choice. It's not your fault, it's just how everyone is. So you got to train yourself out of that. I promise if you write before you pick, you will get more correct answers. So get yourself in that habit. I'm going to write my answer down first. That gives your brain and your hands together time to process it before you just click, and you get more correct answers. So you're going to write your answer down first. If you need to do any adding or subtracting scratch work, do it right there, right here on your paper. You're going to write your answer down first, and then you're going to click. And remember, you get 3 attempts on these. If you have any questions at this point, make sure you're emailing me. I promise I will answer you. I will talk a little bit more tomorrow. You can also Canvas message me, and I'll look at either one of them, but I'll give you a little bit more information on communication as we move forward. But keep emailing me, keep messaging me. Let me know if you have any questions. You got this.